No. This is part 4 of the chapter 1 lecture. Here we are going to discuss how to use the units and how to solve a problem. So just before I get into that, let me remind you where we started this chapter at, where we defined chemistry as the study of matter and its transformations. What does it mean, transformations? Is how do you convert one form of matter into another form of matter? To convert one form of matter into another form of matter, you need to have a calculated study of the measurements of different matters you have at hand and how to mix them together and get a new material, right? So this requires you to do some calculations. That part of calculation is what we are going to talk here. So in chemistry, there is one basic type of calculations that come across again and again. It is called conversion factors or dimensional analysis, where you use a conversion factor to convert one type of unit into another type of unit. So you often have to use the defined relationships between two different measurements, such as I showed you in part 2 of the lecture. For example, I said 1 kilogram contains 1000 grams. So it is a defined relationship. Whenever there is a equality relationship between two different units, you can make two different conversion factors out of it. So you can say like 1 kilogram over 1000 grams or 1000 grams over 1 kilogram. Now those two are called conversion factors. Let's say, for example, here you have an example. 1 inch is equal to 2.54 centimeters. It is a equality because it is a defined relationship. Now, using this equality, you can write two conversion factors. So where they both will mean the same thing because they were already equalities of another. So you would use these conversion factors to convert one type of unit into another unit. So there is a basic structure that I want you to remember. How do you do that? So the purpose of using these fractions is that you are able to cancel out the units that are unwanted from keeping one in the numerator to keeping another in the denominator. Follow this basic example that I'm going to show you. So you should always keep this in mind that whatever the given unit you were told to cancel out should be present in the denominator in your conversion factor, so that you can cancel out these two like this to end up with the final answer. So this is the basic unit that you have to remember. Let's practice a problem using that. Let's say you were asked to use the dimensional analysis technique to convert 12 inches to centimeters. You were told to convert 12 inches into centimeter, which means you need to find the equality relationship between inches and centimeters and write two possible conversion factors and pick the right one to multiply with your given information so that you will end up with a new unit. So as I showed you, this is the basic structure that you should be shooting for. What is the given unit here is inches. So in your two possible conversion factors, you should be choosing a conversion factor that has inches in the denominator. This one has centimeters in the denominator, so you cannot use this conversion factor. But this one has inches in the denominator, so you can use this conversion factor to multiply with the given unit of 12 inches. So if you do that, you will have 12 inches multiplied with 2.54 centimeters over 1 inch. And if you do the math by canceling out the units, you will end up with a number of 30.48 centimeters. See, you were able to convert inches to centimeters by the end of the calculations because you use this basic step of canceling out the unit by keeping them in the numerator and denominator. So here this answer has a correct number of significant figures because you already started with 4 significant figures. So no problem there to worry about. Let's move on and do another problem. Okay. Let's say FDA recommends that dietary sodium intake, table salt, is no more than 2,400 milligrams per day. So convert these amount of 2,400 milligrams per day into pounds, the question is asking. So you need to find the defined relationship between milligram and pounds. But the problem is there is no direct relationship between milligrams and pounds. The milligrams are related to base unit grams, and the grams is related to the English system of pounds, with a relationship of 1 pound is equal to 453 point maybe 6 grams. Yes, 6 grams. All right. So which means you are going to have to repeat the step that we used in the previous problem 2 times. You need to convert milligrams now into grams first using a conversion factor between grams and milligrams. Then multiply that information with a conversion factor that contains grams and milligrams by keeping the unwanted unit to cancel in the denominator in both cases, so that you will end up with the answer of pounds. Okay, these are the equalities that you have for both the relationship. Now you're going to, let me have this. So these are the 2 equalities that you have, and you're going to write 4 different conversion factors that are possible that you might use any one of these 2 here. So now let's see which one you can use. Let's start with the problem of given information, which is 2,400 milligrams. Okay. So given unit is milligrams. Between this and this, which one has the milligrams as in the denominator is the first one. So you cannot use this one, but you're going to use this one. So 1 gram over 1,000 milligrams. So we are going to cancel the milligrams, the unit. Okay. Now you left with the unit of grams at the top here. Now you need to convert the grams into pounds so that you will end up with the answer that you are hoping to end up with. How do you convert grams into pounds is by multiplying with the conversion factor between grams and pounds by keeping the grams in the denominator. So you're going to use this, excuse me. You're going to use this conversion factor. So let's multiply that it 1 lb over 453.6 grams. So grams and grams are cancelled again. If you do the math, you should end up with 0.0059, sorry, 5291 lbs. Okay, that should be your answer. This is how you should use the conversion factors to find the solution for converting one type of units into another type of units. Let's look into this problem where it says an average adult has 5.2 liters of blood. What is the volume of blood in cubic meters? Okay, cubic meters. There is not a direct relationship between liter to cubic meters. So what, excuse me. So what you can do is you can find the relationship between liter and centimeters, because we know that 1 liter is equal to 1,000 centimeter cubes, and you can later convert those centimeters into meter cube. But again, the problem is this one is in cube, but this one has no exponent. So you need to make this one as to the power of 3 as well. All right, let's arrange the problem to solve it. So let's multiply 5.2 liters with conversion factor that has liters at the bottom, because the given unit is liters, so that you can cancel these units like this. what you end up with is centimeter cube. So you need to cancel the centimeter cube with a centimeter cube in the denominator in the follow-up conversion factor. That's why you multiplied this whole equality equation with to the power of 3. Now if you do the calculations, you will end up with the answer of 5.2 times 10 to the power of -3 meter cube. So you propose your answer in meter cube, which is what question is asking. So we are going to have to use this dimensional analysis technique a lot in chemistry. It's almost like the bread and butter of chemistry mathematics. So master this topic as soon as possible.